This is the first video as part of two videos covering working with directed numbers, that's positive and negative numbers. In the first video, I'm going to look at adding and subtracting, and in the second one, I'm going to look at multiplying and dividing. And I'm going to focus on discovering how they work through patterns. So let's start with things that we find really easy and build on that. So let's start with 5 minus 1. I'm sure you know the answer to that is 4. Then we are going to do 5 minus 2, 5 minus 3, and so on. 5 minus 4, 5 minus 5. So we know that as what we're taking away is increasing by 1, so 1 to 2 to 3 to 4, our answer is going to decrease by 1. 5 minus 2 is 3, 5 minus 3 is 2, 5 minus 4 is 1, and 5 minus 5 is 0. So these numbers are dropping by 1, we're taking away 1. So the question is, now, what happens when I have 5 minus 6? So I'm taking a larger number away from a smaller number. And I'm hoping that you can see from the pattern, and sort of makes sense anyway, that we're going beyond 0. We should end up at negative 1. On a number line, if I have my 0 here, my 5 here, we know that if we add, we move to the right. But when we see a minus sign, we have to change directions, which results in a movement to the left. So from 5, I am taking away 6. We know that if I take away 5, it brings me back to 0. So that's if I take away 5, but I needed to take away 6, so that's 1 more, and that will take me to negative 1. 5 to the left plus 1 more to the left. Following that pattern, 5 minus 7 is equal to negative 2. Now, just quickly, we know that 7 take away 5 is 2. When we take away a smaller number from a larger number, well, that's sensible. If I have $7, I take away $5. I spend $5, I'm left with $2. But if I take a larger number away from a smaller number, for students in earlier years, well, they might say that's not possible. How can you? But we know that our number system allows for that, and we need to be able to do that. If I want to spend $7 on something and I only have $5, I might go and borrow $2 from someone, and then I owe them $2, and we represent that $2 with a negative 2. So in adding and subtracting, when we are taking away a larger number away from a smaller number, the result becomes negative. Based on that, if I have 5 take away 10, since I'm taking away a larger number from a smaller number, the result would be negative 5. If you ever need to use a number line, please do so. It's a legitimate mathematical tool to help us work out our answers. So if I'm starting at 5, to take away 10, taking away 5 will take me to 0. Another 5 will take me to negative 5. Okay, now let's build on this knowledge and extend it a little bit more. I'm going to change the pattern slightly. Let's start again with 5. But now I am going to take away 3. Then I'm going to take away 2. Then I'm going to take away 1. Then 0. So 2, 5 take away 2, 3, 4, 5. As the size of the amount that I'm taking away decreases, so from 3, I've made it smaller to 2, made it smaller to 1, my outcome, the result, increases. And again, makes sense. Of course, 5 take away 0 is going to be 5. But looking at that pattern, the next number that I should be taking away is -1. And the one after that, -2. And the one after that, -3. So following the pattern, I would expect this to be 6, 7, and 8. Let's see what's happening on the number line. Let's look at our first one, this one. So I'm starting, let's put our 0 down. Here's my 5. I'm starting at 5. And then we know that when we have a minus, we're meant to go left. But straight after a minus, I come across another minus. And every time I hit a negative, I need to change directions. So this direction refers to the first minus. I've hit a second minus, so I need to change direction again, which results in moving in the positive direction by 1 unit to take me to 6. Another way of looking at this, just to reinforce this idea, if I have 5 plus -1, want to know what that looks like. On my number line, I'm going to mark in my 0, going to mark in my 5, and then I have a plus. Plus tells me go to the right, but straight away I hit a minus, and that means change directions, so that means go to the left. So the outcome is, the final outcome is to move to the left by 1. So that ends up taking me to 4. Number lines are really useful until we become really confident with using directed numbers. Let's have a look at a few more. If I have 5 minus -6, going back here, looks like the two minuses resulted in a positive addition. Here, 5 and 2 make 7, so 5 minus -6 is really the same as 5 plus 6, which gives me 11. Now, continuing our pattern discovery, let's look at what happens with 5 plus 2. 5 plus 1, 5 plus 0, 5 plus -1, 5 plus -2. Now we've already sort of talked about this. 7, 6, 5, looking at the pattern, they're reducing by 1, 4, 3. Let's go to our number line. 0, 5, I have a plus, so I'm meant to move to the right, but straight away I have a minus, change directions. By how many units? By 2 units. So 1, 2, that takes me to 3. So, what I've discovered is that if at any time I see two negative signs next to each other, the outcome of that is the same behavior as if we had a plus. But if I have a plus followed by a negative, or for that matter a negative followed by a plus, then the outcome of those two is as if we are doing a subtraction. And of course, if I have two pluses next to each other, it makes sense for it to be a plus. Now, I could be silly and I could extend this idea, and I could, for example, have 3 minus 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 3. Now, what's happening there? We'll never end up with this, but I just want to reinforce this idea that the first two minuses from my rule that I had, those two together behave as a plus. The next minus, so the question becomes 3 plus, and followed by minus and a 3, and these two operations together from my rule here gets replaced by a subtraction. So it's actually 3 minus 3, which we know is 0.